Couple ideas around complex numbers. The first one being the idea that we have two complex numbers that are equal. What do we know about their parts? So we're given that a plus bi is equal to c plus di in this case. So what we want to look and say, well, we know that a must be equal to c in this case because the real parts must be equal, and b must be equal to d because the imaginary parts are equal. So really, that we're going to do a lot of those in a lot of problems where you have to equate the real parts, you have to equate the imaginary parts. Sometimes it might be saying, okay, where's it purely real or purely imaginary, and you're going to have a look at those ideas and set them to be equal to zero. But they'll occur in a number of problems. The other idea we want to look at in this video is to have a look at the idea of what's a conjugate. Now, you might have heard the term conjugate before. So if I have a complex number we'll call z, which is a plus ib, bi, whichever we want, the conjugate is the complex number where the imaginary part has changed signs. So that's all that happens for a conjugate. And the conjugate's going to be very useful for us to use in complex numbers. So we say the sign changes for imaginary part. So that's the only difference you're going to have. So if we have a complex number that was z is equal to 4 plus 3i, the conjugate of z is going to be equal to 4 minus 3i. And another example, z is equal to minus 3 minus 2i, the conjugate would be minus 3 plus 2i. So two main points here is that real parts in equal complex numbers are equal, as are the imaginary parts, and a conjugate, which is going to be a really useful tool for us to use, and we'll find some really nice results around that, is just where you've got the same terms except the imaginary parts have changed sign.